Hello, everyone. Welcome to today's webinar, Troubleshooting and Conformance Testing for DNP3. My name is Beth Capellis, and I'm the Marketing Manager here at Triangle Microworks. Before we get started, I'd like to go over some housekeeping items and introductions. The webinar is scheduled to be 1 hour long. We will be stopping for questions a couple of times throughout the webinar, and we'll stay on afterwards to answer as many questions as possible. Please submit your questions as soon as you have one. Don't feel you have to wait for a break or until the end. You can submit them online using the webinar menu under the section titled Questions. We have a team of experts ready to answer questions and will respond directly to you, not the entire audience. To be clear, the questions are not seen by the entire audience, only by the folks answering the questions, and will respond directly to you. We will stop a couple times throughout the webinar to read and answer questions. And as I mentioned, we'll stay on after the webinar to answer as many questions as possible. So next, I'd like to introduce the folks you'll be hearing from today. First, we have a Triangle panel of experts, starting with Steve McCoy. So Steve is our senior software developer and protocol expert. Steve has been with Triangle for over 20 years and brings a tremendous amount of protocol and industry expertise to the table. We also have Alan Morrison, our senior technical support engineer. Alan has been with Triangle for over 10 years, and anyone that has worked with Triangle has most likely worked with Alan at some point when contacting technical support. Alan also has a tremendous amount of protocol and industry experience and works every day to help customers solve their protocol issues. Our main speaker today is Matt Green. Matt is a senior applications engineer here at Triangle. He's been with us for about 6 years, and he specializes in QA testing with all our simulation tools and gateway. Matt is also one of our lead product trainers and presenters for webinars and customer demos. So before we get started with today's topic, I'd like to give you a quick overview of Triangle Microworks. We were established back in 1994 and are headquartered in Raleigh, North Carolina. We have customers in over 70 countries and work mostly with equipment manufacturers, electric utilities, and system integrators. The products that we offer all support the standard SCADA protocols and fall into 3 categories. First category is source code libraries. We license source code directly to manufacturers for use in their devices and systems. This allows for a much faster time to market and greatly reduces their costs and development time. We also provide testing tools supporting these libraries and protocols. These tools are used for communication testing in the lab or the field. They are designed to troubleshoot, to simulate, and to automate testing. Lastly, we also provide a SCADA data gateway supported on both Linux and Windows for protocol translation and data concentration with standard SCADA protocols as well as OPC. Now that you know a little bit more about Triangle, I'd like to go ahead and hand it over to Matt Green to get started with today's topic.
Thanks, Beth. So let's take a minute or two and talk about the history of DNP3. DNP3 stands for Distributed Network Protocol version 3. It was initially developed by Westronix and was based on an early version of the IEC 6870-5 protocol standard from 1990. The standard wasn't actually officially published until 1995, but DNP3's roots can still be found in the version from 1990. You might be more familiar with 6870-5 from the 101 or 104 protocols. DNP has 2 different roles, outstations and masters. Outstations have a database composed of the inputs from system devices and outputs controlled from masters, while masters are able to replicate the outstations database and issue controls as previously mentioned. Unlike proprietary protocols at the time, DNP3 was an open standard, which encouraged different vendors to use compatible protocols to allow for interoperability. A DNP3 users group was founded in 1993. They help enhance and maintain the protocol. This slide is going to talk about the way that DNP3 connections can be created over TCP/IP. DNP3 connections can be issued from either the master, the outstation, or from both. While either can initiate the connection, the outstation can limit the IP addresses from which the master can connect from. And as with all TCP IP connections, you'll need to designate a port. DNP3 spec defaults to using port 20,000. If your devices are not connecting as you'd expect, there are a few steps that you can do to troubleshoot the issue. The first thing you'll need to do is to understand the architecture of your devices. This includes understanding the roles of the devices, which acts as the outstation, and which is the master. You'll also need to understand the type of connection you're attempting to communicate on. The next thing you should check is which of the devices is set up to be the initiator, or TCP client, and which of your devices is the listener, or the TCP server. Also, remember sometimes both can initiate in a dual endpoint configuration. If all of this seems to be configured properly, you can check the IPs and the port, and then the source and destination addressing. While checking the IP addressing information, your outstation isn't restricting connections from the IP that your master is using. Once all of this has been checked out and your devices are connected, you should see data link status requests. These are a form of keep alive messages to verify that your devices are remaining connected. While TCP/IP does have a built-in keep alive message, the rate at which it's checked is far too slow for some DNP3 connections. Before we start with our first demo today, I'd like to talk a little bit about the applications that you'll be seeing today. Wireshark is a network protocol analyzer. It listens on the network adapter and analyzes packets that are being sent across it. It can be used almost anywhere, including in labs, testing environments, and out in the field. The protocol test harness is an application we'll be looking at the most today. The test harness is a diagnostic protocol simulation tool used to test and monitor an individual device's behavior. It can be used in a wide variety of situations, including in development, in testing, in labs, and even in the field. The test harness supports DNP3, Modbus, 6870-5, 101, and 104. The last application we'll be looking at today is Distributed Test Manager, or DTM. The Distributed Test Manager is another protocol simulation tool, but this one is more focused on simulating entire systems of devices. DTM is generally used in the lab or in testing environments. Today, DTM will only be simulating the hardware that we're performing tests on. But if you are interested in more information on this tool, we have other webinars whose main focus was on using DTM. So now that you've been introduced to the application shown today, let's take a look at how you can troubleshoot a DNP3 connection over TCP/IP. So this is the applications we're going to be looking at today. We have DTM, or Distributed Test Manager, on the right-hand side. And then we have different folders depending on which demo we're going to be looking at. For the first view, we're going to have the outstation as the device under test, and that's simulated in DTM. And we're going to have the master inside of the protocol test harness. And what we'll see right off the bat is that we're getting a bunch of errors when trying to open a connection. So what we can do here is there's two ways we can troubleshoot why this is happening. The first is you could bring up Wireshark. I'm going to go ahead and search at the IP address 15.16.17.102. I know that is my master's IP address, so I just want to see what is going on. So I'll go ahead and start that up. And then I will stop it just so we don't have it continuously screening past. So what we're going to see here is we're going to see a connection request and then a response to that connection request. Then we're seeing an acknowledge, everything seems to be connected. And then at the end, what we see right immediately after is this fin or finish, which is effectively closing down the connection. And that close is coming from 15.16.17.100, which I know is my IP address of my outstation. So it looks like the outstation is closing this. You can also see this in the test harness. So in this middle section here, we have what we call the protocol analyzer, and we're seeing the traffic going across the wire that's involved with the devices in test harness. Currently, I have the target and physical layer filtered out, but if I enable this to get more information on what's going on, and then I'll just pause the display, what we'll see is a TCP channel is being opened. It was successfully opened, and then it was connected. And then almost immediately after, we're seeing that it was closed due to the remote side or a connection failure. So again, we're seeing that the outstation is the one that is closing the connection. So let me unpause this, clear it to keep going. So now what we're gonna do is we're gonna go through the troubleshooting steps we talked about before. I've already laid out that which is the master and which is the outstation. So we know that architecture. We can also look to see what we're going to be communicating on. So if I right click in the test harness and do modify session and go here to the channel, we'll see that we're communicating on TCP, which is what we are trying to connect on. So that's correct. We can also go into the advanced settings here to look to see if we have a correct initiator. So if I scroll down to this when TCP mode, we'll see we have a client. So yes, as the protocol analyzer is saying, the master is trying to initiate the connection. The next thing we're going to want to do is look at the addressing. So I'm going to look at the sessions tab, which has our link layer addressing on our DNP3 master in test harness. And I'm going to try to make sure that my device under test or my outstation here is configured correctly as well. So I can just come here and do edit the session. So what we're seeing here is that the outstation is configured to have a source addressing of 4 and a destination of 3. So the source of this outstation is 4 and the destination of the master is 4, so these will communicate. And vice versa, we have the source of the master as 3 and the destination of the outstation as 3. So that all seems correct. So now let's go look at the IP addressing for TCP. So I'm going to go up to the IP information on the configured device under test, and the same for the DNP3 master. So we'll see that the host, which is the device that the master is trying to connect to, should be at 15.16.17.100, and sure enough it is, so that's correct. They're both communicating on port 20,000, so that's no problem. But then on the last stage, what we see is where our issue is coming about. The remote addressing on the outstation side is 15.16.17.101. So it's only going to accept connection requests from 101, whereas our test harness is simulated and is running at 102. So I could either change this to be 101 on the master side or realize that my device under test is misconfigured. I can go ahead and change that to 102, hit OK, close this down. And now what we'll see is those error messages have stopped coming across. So now we've got our connection and some information is being sent across. And immediately afterward, what you'll start seeing is those link status requests if your device is configured to do so. So if we sit here and wait a little bit after they finish kind of all their handshaking, you'll see, let me pause it so it doesn't go off screen, we do start getting these link statuses. And it's just going to send those back and forth to make sure that the devices are still connected and that we have not disconnected. You can also see this again by going to Wireshark. And this time, I'm going to go ahead and start it back up. But at this time, instead of searching on the IP address, I can actually just type in DNP3 here and click filter. And it'll filter out everything on that network adapter except for anything related to DNP3. And sure enough, we're seeing these link status requests being sent back and forth. So that is the first demo we're going to be going over today. I'm going to jump back over to the PowerPoint for a few slides to talk about monitoring. So in the last example, we were able to simulate one side of the communications, but sometimes you need to be able to decode communications between two real devices, or you are unable to simulate either one to recreate a problem. This is when you can use monitoring to help you diagnose the issue. Monitoring is the act of listening or sniffing the wire to gather information about communications on it. Once a monitor has been configured properly, you can use filtering options to narrow down the amount of information that you're seeing in order to help you locate your issue. You can also use a recording feature that's included in some monitoring software in order to keep a log of what you're seeing in case you need help from others, such as technical support. So now we're going to talk about how you can set up a monitor within the test harness. So I'll minimize these for now, and I will bring up a brand new empty test harness. So in this situation, I don't have the device pre-configured or anything, and I'm going to walk through those steps with you. So what you're going to want to do with the empty test harness here is go to Open, and then Monitor Channel, and then you want to do DNP3. From here, there are a few different ways that you can communicate with the devices. You've got serial, such as a standard RS-232, as well as a radio network or RS-485 multi-drop. So we can use that type of connection. We can use TCP/IP, which we will be today. But it's also worth noting that we have the ability to input bytes captured by another tool and parse them directly in the test harness. And that's what raw input bytes is. We're doing TCP/IP today. I know the master is at 15.16.17.102, and the outstation's at 15.16.17.100. I know the port is still 20,000, and I'm going to choose the adapter in which it will be able to communicate on and hit open. So what's going to happen is we're going to get a monitor channel here on the left-hand side, and that's effectively all we're going to see right now. Now, any sort of traffic that's being sent along that channel of communication, we should see pop up in our test harness now. So I'm going to go over to my devices under test, and I'm going to issue an integrity data poll, which is effectively just the master asking the outstation to give them everything in their database. So I'm going to issue that command now, and sure enough, now we see it here in the test harness. So even though the test harness is not the master or the outstation in this communication, we're still able to see the information traveling across. And so we're seeing all the double bits come across, the binary inputs, just everything inside of that outstation's database is being sent over to the master, and we're able to see that on the line. So how can this be used to actually track down, say, troubleshoot an issue that you might be having between the two devices? Well, I'm going to go ahead and issue a control to point 5 or index 5 from the master to the outstation. So I'm issuing that control now. And what we're seeing here at the bottom is that there was a parameter issue. The value did not update in my outstation, the control was not successful, and there was some sort of parameter issue. So I will bring up the control editor in my master and bring that over. So you've got many options here. You've got your different modes. I'm looking at all the parameters since that's the area of the issues. We got select before operate, that's correct. Qualifier code, that seems correct. We're doing a latch on, that seems correct. But I was trying to control the point at index 5, and I have 50 in here. So just a simple mistake here. If I go ahead and clear that, and I'll clear the display, bring this guy back up. And now if I issue the command, what we'll see is it come across, and sure enough, there's no more error. The value did change in my outstation, so that was all successful. So just kind of a way that you can use the test harness to track down a very simple issue that could be potentially causing problem between two hardware devices or a device that you won't be able to simulate. So now that we've talked about connections and getting devices up and monitor channels up, we're actually going to stop for our first section of questions. So I'm going to pass it back over to Beth and see what she has.
Okay, yep, we do have a couple of questions that have come in. So let me just kind of take it from the top. First question. I saw opening UDP endpoints in the test harness protocol analyzer output when it was configured as a DNP master. I thought we were using TCP for the connection. Can I hand that over to the panel? Steve, Alan, do you want to take that?
I'll take it. So yes, it did say that. When you use TCP, typically you also open a UDP port that's used by the master for sending broadcast requests to the outstations. The outstation similarly would open a UDP port to listen for those broadcast requests. Your broadcast needs to be sent to a broadcast IP address. So this only typically works on a subnet. It's a key thing about broadcast is there are no responses to broadcast. So while the requests are broadcast over UDP to the outstation, no responses come back to broadcast requests. The master does not listen for broadcast, does not listen for UDP to get responses. There is a UDP only mode in which requests and responses would be sent both ways, but that's a different scenario.
Okay. I've got a second question here. I think this one's going to be for you as well, Steve. Do I always have to use port 20,000? Suppose I want to allow 3 masters to connect to the outstation. Don't I have to listen on 3 different port numbers?
So the DNP spec says the default is 20,000. Every outstation has to be able to listen on port 20,000. Every master has to be able to connect to port 20,000. However, if your device is capable of it, you can choose to listen on different ports. You can choose to connect to that same matching port from the master. So it is not required to always listen on 20,000, but it is required to have that capability. And as far as multiple connections, if an outstation supports multiple masters connecting to it, it can still listen on just a single port number like 20,000 and can accept connections from multiple devices on that port number. Or it could choose to use 3 different port numbers if that was desired. So either way works. Routing is done for you even if you use the same port number. But it depends on the outstation, what it supports. That is a key point.
Okay. We do have a bunch more questions coming in, so let me just keep going for a couple more of them. Do we have keep alive messages in other SCADA protocols like 61850, 101, 104? What are they? Steve, do you want to take that one?
Yeah, I'll take it. So let's see. 101 would be over a serial link. It can either be balanced or unbalanced. If it's unbalanced, the master's polling, so there'd be no need for. I mean, that's the equivalent of a keep alive. I mean, it's constantly talking. 101 balanced, there are no keep alives, but it's also not over TCP. The point of the keep alives was to make sure that the TCP connection doesn't go down and need to be reestablished. So 104, yes, there are link layer keep alives. They're called test frames. 61850, I can't really answer, but I'm sure I would imagine the answer is yes, but I couldn't tell you what they're called. I don't know if anybody else has.
Yeah, I think 61850 depends on TCP keep alives.
Okay. Next question. Could the test harness import PCAP traces?
So yes, yes, sort of. Yes, you can. You can output Wireshark or PCAP traces to a file, and you can massage the data in the file so that it can be imported to the test harness. One of the features we're actually currently working on is to simplify that process, but yes, it can be. And there can be value in that because sometimes Wireshark, I'll talk about Wireshark, you asked PCAP, but Wireshark, sometimes it doesn't know the latest things in the DNP protocol. For example, secure authentication is not, I'm sure it depends on the version of Wireshark, but it's not completely implemented. So yes, you can. It's documented in the manual how to do it, but there are commands that you can use to import bytes of data that were outputted from Wireshark.
Okay, I will take one more question and then we'll move back over to the slides in the demo. Alan, I think this one might be for you. How do I save the protocol analyzer log? Alan, do you want to take that one? You're on mute.
Hi, everyone. Sorry about that. Yes, you can select the File tab on the Protocol Analyzer GUI, and then go to Save Protocol Analyzer, and then it'll pop up two options. Either you can save it in text format or XML format. The text is just plain text. If you save the log in XML format, you can load it back into the test harness, and it provides the display capabilities of the Protocol Analyzer as in a live capture. It allows you to filter, deselect, search. Also, these when you save the Protocol Analyzer log in XML, it gives you the capability it stores the configuration for the channel and the session, so those can be examined and looked at, so you know what settings were used when the protocol log was captured.
Great. Okay. Thanks, everyone. I think what we'll do now, a lot of questions are continuing to come in, so we'll go back to answering those online. And then Matt, if you want to go back to the presentation.
Yeah, absolutely. Let's see. So now that that question segment is over, let's get back to a few more examples. When testing an outstation, you might want to use a test set. A typical test set is simply just a simulated master. A DNP3 master simulator allows for sending messages and controls to the outstation from a single master or even from multiple masters. This will allow you to test your outstation in various situations without requiring the actual hardware. Other tests you can perform with a simulator is sending bad messages from the master to the outstation and verify it performs properly under these abnormal situations. These bad messages may not be easily sent from an actual hardware master device. So let's take a look at how you can simulate a DNP3 master in the test harness. So I will put this one down, and I will bring back up the two we were looking at before. So again, we have our outstation, or our device under test simulated in DTM, and we've got the master from before. And then what I'm going to do is I'm going to take a look at showing you how to set up a master channel. So we do have a device here, and as mentioned before, you can modify this and go change your parameters. But if you don't have any device, you need to open a new device. You just go to File. You just go to Open, and then you do a master session, and then do DNP3. This is going to bring up your configuration for that master. So we've got our link layer addressing, which we talked about previously, the source and destination. If you do have secure authentication, as I think one of our questions had some information about, you could enable that here. The channel tab, this is when you'll choose either serial or TCP/IP. If you're doing TCP/IP, you put the address of the outstation you want to connect to. If you want to specify the IP address that you're communicating on, you can choose that from the local IP. Just do a drop down here. And by default, the port number is 20,000, but as mentioned, you can edit that if needed. There's also an advanced settings on both of these tabs to allow you to go in and change some configuration information for very specific situations. So if you want to monitor something, or if you want to simulate something that may be exactly out in the field, you might need to come in here and change buffer sizes and timeout times and things like that. But I would say 80% of the time, everything that you need to get a simple connection up and running, you'll be able to do directly from these three windows. I'm not going to create another device right now, as we already have one up and connected to our device under test, but there are a few other things I can show off on the master side. The first is if you do open data window, what that's going to do is it's going to give you kind of this default view of all the data in our system. So if you drill down into it, you'll see all of the devices that are inside of the test harness. Currently, we just have the MDNP device, and if I continue to open these up, we'll be able to see all the different data types inside of it. So we've got our binary inputs, our double bit inputs, our analog output statuses, we have analog inputs, we have all the different things that you might want to see. But what you'll also notice is that all these values are fairly static. They're just sitting there, nothing's really changing. And on my outstation, nothing's really changing either. So what I can do is go over to my outstation, and I'll just interact with it and cause data values to change. So I'll just click change once. Now the data points inside of my outstation have all changed. But again, in the test harness, we're not seeing those values coming across. And that's where commands can come in. So if you go to open the command window for DNP3, that'll bring up a window that looks like this. And what this is this is a way for us to be able to issue commands and controls from the test harness. So the first thing you want to look at, especially if you have multiple devices here, is this target. This is effectively who is sending out the command. Currently, we only have this one MDNP. And so when we send any command or control, it'll come from that. And then we've got some default data or default commands out here. We've got our integrity data pull. We've got our control relay output block, enabling and disabling unsolicited messages, just to name a few. So when I click integrity data pull here, we'll see all those values come across the screen into our protocol analyzer. And then from there, now if I bring back up our data window, sure enough, we'll see, just because I left it on analog inputs, we'll see all of our analog input values have now updated to what they are into our outstation. You can also run. Can someone, one of the organizers, mute? Hearing a bunch of keystrokes. You can also update, you can also issue controls in other ways. So we have, say, our control relay output block. If I want to edit that, I can either right click and then do configure command, or I can just double click on it. And this will bring up the configuration editor we were looking at before. So again, we can do select before operate, we can do direct, no acknowledge, just to select. There's the different qualifier codes. You can interact with which index or which point number that you're going to be performing this control on. You can do latch on, latch off. You've got trip, close, everything along those lines. And you may want something to happen not just once, but say periodically. So you can actually set up this certain control to happen periodically. So there's the repeat interval here. You can set up what that is. Now, maybe for a control that doesn't make too much sense, but maybe if you were doing integrity data pull, you'd want to set it up for once an hour or something like that, just to make sure your database is up to date. And while we're not talking about it now, it is also worth noting that once you configure a command how you like it, it actually will give you a tickle command. And if you copy this out, this is the exact command you would use while scripting to perform that exact same control that you have configured. And scripting will be one of the demos we're going to talk about later on, but I did want to point it out while we were here. So if I close this, then I can issue a control, and the control will go across. You see that the binary command is being sent, and that will be able to be sent from the master to the outstation as well. So there's one more thing I wanted to talk about when it comes to simulating masters, and that is simulating multiple masters. Again, you could go to open and then do a master session DNP. We talked about this before. You can set up your IP address, your port number. You can select your local port or local IP address. But what if instead of communicating on port IP 102, I wanted to do 101? I could change this and connect up to a totally different thing. And then just hit open. And that'll bring up an entirely new simulated master with individual session information and TCP IP information here. So you might want to do that if you're connecting to two different outstations, or if you're connecting two different masters to the same outstation. There's another way that you could do it, and that you could do that by adding an extra session to an already previously created channel, which is the TCP IP connection. One reason you might want to do this is if you have one TCP IP connection to a remote terminal server, which then will split that up into multiple serial connections to different outstations. So to do that, you would just right click on a previously created channel and add a master session, and it will give you the configuration just to create another session down here. So let's just pop these up to and click open. And sure enough, now we have another session down here that could connect through, like we were mentioning earlier, a remote terminal server or something like that to allow one TCP/IP connection with multiple link layer session information. So let's jump back over to the PowerPoint. So now let's talk about simulating an outstation in Test Harness. You may want to simulate DNP3 outstation traffic for multiple reasons. One reason is to test large volumes of messages being propagated in your system to test your master device under a heavy load. You can test performance of your master device, how it will respond to large buffer sizes, or even overloads. You can also generate data from a single or multiple outstations. In order to verify the behavior of your master device, by simulating outstations, you can also verify that your master supports all the features that you'll need once it's been deployed to the field. You can also use a simulator tool to verify that your device has also been properly configured before deploying it. So in this scenario, we're given a master device who seems to disconnect at seemingly random times. So we've configured our test harness's simulated outstation to match the field outstation as much as possible. Our hope here is to recreate the disconnect and track down why it's timing out. So let's go ahead and look at that. I'm going to go over to our DTM, our device under test tool. We need a master in here, not the outstation. So I'm just going to right click manage and disable all the devices from the first 3 demos. And then I'm going to go down here to demo 4 and enable this device. Now, in order to test our master, which is our device under test, I need an outstation in test harness. So I could configure a new device here for you, but I've already created a workspace before the webinar started to match the configurations of this theoretical device in the field. So I can just go File, Open Workspace, and then go to Demo 4 and just open this up. So in this situation, what we're seeing is we have our master here simulating DTM and our outstation in test harness. We are seeing that the devices are up and connected and the information is being sent across. So what we can do is test to see when the master times out and when the failure occurs. So we see that it's not disconnecting. There's no errors with it just sitting here. That all seems fine. So let's add another layer of complication to it. So to do that, I'm going to go from my master and just issue an integrity data poll. So I'm just going to go ahead. Let me clear the display, issue the command. So sure enough, the integrity data command is coming across. It's grabbing all the information inside of the outstation. It's being packed up and sent back to him. His database is updating, so that all looks good. So now let's add another layer of complications on top of it. Let's go ahead and change some of the data inside of our outstation. So I'll go to Open Data Window, as we've seen before. This time, because we have an outstation in here, we can actually interact with the data. So I could go to these binary inputs and I could toggle that value. I could go to these analog inputs and all these guys are at 50. I could, edit one at a time, or I can multi-select, and let's just change these analog values. I'm going to change them to say 200 from 50 and click accept. So what that's done now, it's actually gone into our simulated outstation in test harness and changed all those values that I interacted with. And the reason I did that is because now I'm adding event data on top of the values that we're already sending across. We're going to see if not only the integrity data poll can be successful, but if there's event data, will it also be successful? So let me clear this as well and go ahead and issue that command. And we're seeing the same thing come across. Everything looks fine. The values are coming across. But what I'm seeing is the database in the master is not updating. And sure enough, after a little while, we do see that timeout. So I'm trying to think about what exactly we did in between when it was working and when it wasn't working. And what we've done is we filled the packets that we're sending across with more data. So I'm thinking maybe like some sort of overflow has occurred. So I can go in and look at and reconfigure my master. So if I right click here, I can go and edit its configuration information. And I'm going to go over to the advanced tab here. So I'm looking through here for overloads, for sizes. And one thing I notice, because I just configured the Outstation and test harness, is that the receive fragment size is 1024. I know the device that this master eventually needs to connect up to in the field actually has a receive fragment size of 2048. So what's effectively happening is at the 1024 level, we're able to get all of the information across, all the static information. But as soon as we start layering on event data on top of it, it breaks this fragment size and the timeout occurs. So I'm going to match the configuration here to 2048 that I know is the device that it will be connecting to in the field and how I've configured the test harness to connect to it. So I'll hit OK. It'll restart the device up. And then we need to go through kind of the same steps. We see the devices have connected. We're not seeing any issues. So I'll go ahead and clear this. I'll go ahead and issue another integrity data pull. All that information is coming across. Again, we're not seeing any issues. And then I will come down here to this event data and I will change the values and I'll change it to say 500 this time. Those values have all updated now. And if I issue this, well, let me clear just so we can make sure we don't see it. If I issue the control here, we see all the values come across. We're not seeing that timeout. If I go and look in my master device, I actually do see that the values have updated, so that all seems correct. So that's one way that you can use the protocol test harness as an outstation to track down maybe configuration errors or something along that in your master device. Let's say you were unable to find the issue and you had some information from your history of the tests that you've run, and you did want to output the log as one of the questions asked during the last Q&A session. Just to tag along more information, yeah, you would just go over here to File, and then you've got your Save Protocol Analyzer. We've got text and XML. You could then output the tests that you've run, the diagnostic information you have, and potentially take that to a coworker or someone who maybe more has more experience with the protocol and see if they can help you figure out what you saw potentially in the field after you send it back to them in the office or something along those lines. So now we're going to go back to the PowerPoint, and now that we've talked about how to simulate outstations and masters in the test harness, we're going to have another question segment, so I'll hand that back over to Beth.
Okay, yep, we do have a bunch of questions coming in. Let me start with this one. I think this one's going to be for you, Steve. I noticed that error messages were in red in the test harness protocol analyzer window. Is that always the way, or are there other message certain colors?
So yes, they're red, but that's just configured that way. You have the ability in the test harness to open a configuration window for the protocol analyzer, and you can choose colors and fonts for each layer of the protocol for specific types of messages like errors or different data or events, static data or events. And you can color the transmit and receives differently if you choose, or like secure authentication, you can make a different color. So you have the ability to choose colors or fonts that maybe would help you isolate what it is you're looking for quickly in the protocol analyzer. You also have the ability to turn layers off in terms of filtering, but if you want to set the colors in such a way that, red's good for an error, but whatever is good for you, you can set. And it gets saved, if you save the workspace, well, actually you don't, just when you exit the test harness, it saves that configuration as you're in a settings file.
Okay. The next question might have a couple of different answers to it. So let me read it. I'll hand it over to the panel, and Matt, you might even want to add a little bit to this with some insight into DTM, the other tool. How can you change points continuously? Example, take analog input in and increment automatically.
So yeah, I can take over that one. There's a few ways. Let's talk about both the test harness and DTM. In test harness, one of the last demos that we'll be going over today is scripting. And Steve, correct me if there's a better way, but how I would do that in test harness is you could just write up a quick script to change the values, and then you can use the previous value as the new value. If you have an analog value, you could increment that by adding a certain just flat value to it, a random value. I mean, with scripting, you have all the power in the world, and you could just pretty much run that to allow changing. And the same thing could be done in DTM. If you are using DTM as a simulator, we have the ability to use scripting as well. We also have 2 other ways in DTM to simulate, a full system of device test. You can use a CSV file and just play that back continuously. So you have different states for all your different devices and all your different data attributes inside of each of your your devices. So you can run that on playback. And we also have a tool called Auto Data Changes, which is basically just dummy data. You go from, analog values from 0 to 100. You can ramp, you can do sine waves. You can do different type of things like that. You can even do random values between a max and a min point, and you can periodically change it every second, minute, hour, however you want to configure that up. If there is a better way, or you have another suggestion I may have missed in the test harness, feel free for any of our panelists to unmute and let them know.
That sounds like lots of answers. I mean, you can also do in the command window that, it can do something every time period. You could have it change values. And I don't know if you said it, but C# or Tickle C# plugins you could write. So lots of possible ways to do it in the test harness and in.
Okay, thanks. And just a follow-up question to that. Someone had asked a little earlier in the chat, do we require a separate license for DTM, or can it be used on the same dongle as test harness? And I can answer that. I mean, DTM is a separate license that is purchased through Triangle. It can work with test harness. It can be available on the same dongle as test harness, but it is in fact a separate license from test harness. I'm going to do one more question, and I think we'll go back to the presentation so we make sure we cover everything in time. The test harness log looks very similar in usage as compared to Wireshark. I was under the impression that Wireshark is actually embedded in test harness. Does someone from the panel want to take that?
I'll answer. Yeah, so Wireshark is not embedded in the test harness. Monitor mode using over TCP, so when you're monitoring TCP channels, does use WinPCAP or whatever its new name is, but there's a new name for it, but WinPCAP. So, the same base that Wireshark uses to actually do the sniffing, but the decoding is done by the test harness, not by Wireshark. So, they are actually, the display and the decoding is completely separate. The sniffing of the TCP is the same between Wireshark and the test harness.
Okay, thanks, Steve. Matt, if you want to go ahead back to the presentation.
Yeah, absolutely. So there's 2 more demos I need to go over today. These can be seen as more of the advanced topics of the things that we're going to be talking about. And the first is conformance testing. The DNP3 users group maintains a testing procedure that will verify your device's conformance to the DNP3 spec. The tests can be executed by the vendor or a third party, but the results logs must be verified by the DNP users group. Recently, the users group has dedicated some more time toward improving the certification process. The benefits to having your device pass this test is to prove that your device is more likely to be interoperable with other vendors' DNP3 devices. The conformance test is customizable based on what features your device supports, and all of that is defined in your XML device profile. The test harness application has a tool that allows you to pre-test your device and find issues early on in the development process. In fact, some of the third-party test houses use the test harness to test the DNP3 conformance. So let's take a look at an example of conformance testing. So in this situation, we want to run the conformance test on the device under test, and that device under test would be an Outstation. So again, I'm going to go ahead and disable the master here, and I will go down to my demo 5, which is the conformance test one, and enable an outstation for us to perform these tests on. I'm also just going to close the workspace here and start with a blank page to allow us to show you how to build up the conformance test altogether. So again, as we've done in the past, you go up to open, and then you've got conformance test and DNP. So from here, you're able to then take a look at all the tests that will be performed. You can select these tests individually. You can select all level 1 tests, all level 2 tests. You can select everything, deselect everything. Reset state will just put everything back to how it was when you first opened it up. And then we've got a few other things here for connecting and executing the tests and things like that. But I mentioned earlier about how all this is customizable based on your XML device profile. And so the conformance test needs to be within Test Harness as well. So to do that, you go to File and do Edit Configuration. So if I do that, what it will do is it will bring up the configuration for the DNP3 conformance testing. So from this very front tab here, this general setup, we're able to choose what data types we support, the application layer information. So here's some of the fragment sizes we talked about before. If you support unsolicited messages or not, this will allow you to kind of customize all of this. For the sake of this demo, I don't, want to go through and show off the entire conformance test just because it might take a little while. So I can show that, you can disable these different data types, and along the top here, you'll see that the different configurations for the tests are being enabled or disabled. So for this case, I'm going to be looking at analog outputs. I can go over to the analog outputs and configure the tests. How this configuration works is effectively anything that needs to do select before operate. It's going to use whatever this point index is. This is the initial value that it will be set to, and this will be the value it will be controlled to. So all of this is completely editable. So if your analog output index 1 doesn't support select before operate, you would want to change this. Otherwise, you could leave it as is. And then all the different functionalities that we might be performing on analog outputs will be listed here. And the values, initial values, the test values, things along that can be configured as well. So now that we've done that, the next thing we'll want to look at is how to actually connect up to our device under test. So that would be under the Connections tab here. And as we've been doing today, we've just been using TCP/IP, so I'll stick to that. I know my host, my outstation that I'll be connecting up to is, again, 15, 16, 17, 100, and the default port number of 20,000. So if I hit close here, what we'll do now is we have now configured our conformance test to match the information on our outstation. So I can click connect, and what that'll do is it'll create a master based on the connection information we have. If we want to just be super confident that everything's connected, I can do a general interrogation, and sure enough, all that information is coming across. So now let's actually run some tests. So I'm pretty sure I had binary output tests. I'll just go down here and grab a few of these guys. So I'll select maybe these 4 here, and I will execute those tests. So what we will see is the log is now filling up here to allow us to see what's going on during each of these tests. And then at the very bottom, once I only did 4, these 4 tests have run, we'll see the number of tests was completed was 4, 2 of them passed, there was a warning for one of them and a failure for one of them. And you can see that here at the bottom. You can see that as you scroll through the log, the different colors. So red is a failure, orange is a warning, and green is a success. You can see that there. Also, if you don't want to scroll through the log, because say you did, every test, you can see over here on the check marks, a green check mark, obviously pass, red, failure. So you can get the information like that as well to be able to see what's happening. You can actually save this off. So if I do file, save test execution, I can then save that off to an output file somewhere. So maybe we can test today's performance with tomorrow's, maybe update or something like that to see if we've resolved whatever the failings or warnings might be. It's also worth noting if you're going to be testing the same type of devices, instead of editing the configuration every single time you come in, it might be a good idea to, after you edit it to what you want it to be, save that off again to an external file somewhere. And then when you come in and load up test harness next week or tomorrow or whatever it is, you can just load that configuration in rather than having to reconfigure it each time. And as I mentioned before, you can click reset state here, and that'll reset the state of all of your tests being run. And you can clear out the log here as well to get you back to the original state. So that's how we work with conformance testing. One other question we get asked a lot is about automation testing. So let's take a little while to talk about automation testing. Automation testing is a large part of regression testing. There are many reasons to implement automation testing, and a few are shown here on the screen. Specifically, I'd like to talk about testing variations and its effectiveness. Certain tests can be repetitive and follow the same process over and over, and the only difference between these tests are slight variations of the inputs. This is a perfect type of thing to automate, as automating one process can test many different requirements all at the same time. It also frees up the human who used to perform those tests to perform more complex things, which may be harder to automate. Automation testing in the test harness, as mentioned in the previous Q&A, is done through Tickle and the C# plugins. So I'm going to go back. I am going to go ahead and disable all of my devices inside of my DTM tool, and I'm going to show you how automation works. So what you can do with automation is you'll be wanting to interact with the Tickle interpreter down here. So you can do, just for example, DNP help. If I hit that in, it's going to give us a detailed description of every sort of command that's built into the test harness about the DNPs. It'll give you the name of what the command is you need to type and a little bit of information about what it does afterward. So if I scroll here to the bottom, I'll just look at this bottom one here. It's DNPDB for database, and I'll just put a question mark afterward. That'll give you all the parameters that are required and optional for this specific test. From here, you could obviously learn what all of these functions do and what they are, and come in here and type out any sort of things you want to do, say creating device, issuing controls, et cetera, et cetera. But once you get comfortable with that, you can actually bring up something like Notepad++, and then type in, say, DNP, DB, and then all the parameters that you need, and build up a script. We don't have a lot of time left today in the presentation, so I'm not going to try to script something for you here live, but what I can show you is we do have this demo script. This demo script is something I made beforehand. It's based completely on a built-in script that we provide with every test harness install. I've simplified it. I've cut it down by maybe half, or maybe cut it into a third. I effectively have a main function here. I've got a command that I've built here that runs all the commands. I've got a section here that just creates devices, so it creates one master, one outstation. And then of course, I've just grabbed all these functions from the script I was talking about to actually issue commands. So now that I've written up this script, I can just go ahead and type source and give the location of where the file is. And hit OK. And now that I've done that, Test Harness not only knows about all the pre-built-in commands, but also all of the new functions I have in that script. So if I do run DNP now and hit enter, it's going to execute the main function, which I named run DNP. So what it did is it created an outstation, it created a master, and now it's waiting 10 seconds. So sure enough, there's a master and outstation here. After the 10 seconds is over, the master then issues a binary command, an analog command, and does an integrity data poll. There's no errors or warnings. Everything ran through properly. Sure enough, we're seeing all this information come across in the protocol analyzer here. It's also worth noting if I just deleted out this run DNP and this closing bracket here, when I sourced this file, it would learn all of the functions that are built in and then just issue these commands one by one. You could also just copy and paste from your script into this output or into this interpreter here to run your tests as way. So there's a lot of different ways. I've only touched on Tickle today. There's also the C# interface that you can do. But there's a lot of different ways that you can automate your tests and have these things run while you're working on more complex tests or getting a coffee or overnight, or some people you do nightly build type things. So automation's definitely a feature we focused on with the test harness. So let's get back to the PowerPoint. We've looked at the demo for scripting. I am now going to hand it back over to Beth for our final thoughts. And then, of course, stick around afterward. We will be finishing up our Q&As and answering as many questions as people put out there for us. All right, Beth?
Yep, thanks, Matt. And we made it just in the nick of time. It's 11 o'clock now at 1 hour. So the webinar will be posted, the recording of a webinar will be posted on our homepage at trianglemicroworks.com. You will also receive a follow-up email that will have a link to the recording within the next 24 hours if you respond to the survey. So once you close out of here, you'll get a very short survey. It's 3 questions. We'd love to get your feedback. And as part of the response from that, you'll get the recording to the webinar itself. And we also will be posting it on our YouTube channel. Please go ahead, and if you'd like to keep tabs on our upcoming webinar, if you go under the training tabs on our website, you'll always see the latest webinar that we've come up. We typically are doing them on a monthly basis. And you could also sign up for our newsletter. That sign up is right on our homepage of our website. That will allow you to get email updates for upcoming webinars and product releases. Now, with the tools you saw here today, Test Harness and DTM, you can also download evaluation licenses to both of those tools and try them out firsthand. And certainly, if you have any questions or additional comments, please feel free to email us directly at sales@trianglemicroworks.com. So with that, I want to thank everyone for their time. As we mentioned a couple of times, we'll continue to stay on. We do still have some questions coming in. So I'm going to read through some of those and answer that. Whatever we did not answer today online, we do send out the question and answer spreadsheet with all the answers in a follow-up email, probably about in a couple of weeks. So you will get an answer at some point if we were not able to answer you online today or live on the webinar itself. So with that, again, anyone that wants to stay on for a couple more minutes, please feel free to continue to enter some questions. I'm going to go ahead and engage the panel again and ask a couple, or read off a couple more questions. So with that, I'm going to hand this over probably quickly to the panel. Someone did ask about support for subset level 3. Does Test Harness have support for subset level 3? Does someone from the panel want to take that, Steve or Alan?
I'll take it. Specifically, I think that the question was related to the conformance testing, but I'll answer it in general. Test Harness supports well beyond level 3 in terms of the functionality of DNP. If you all know, level 1, 2, 3, 4 are defined for DNP. They have different functionality. The conformance tests were recently updated to include level 3 testing, and the version of the test harness that Matt was showing is 328. That did not have level 3. The next version out will include level 3 testing as that spec is released.
Okay, thanks, Steve. Does any of conformance testing require pre-approval from Triangle for patent issues or so on? I think that might be another one for Steve.
Yeah, I'll answer that one too, because it's all related. And as long as you license the test harness and license performance testing tool in the test harness, you can use it however you want. So no, there's no issues about how many devices or anything about patents or license. Again, as long as it's licensed, you can use it to self-test. You can test other people's devices that you're buying or whatever you want to do. No restriction.
Mm-hmm. Here's another one on conformance testing. Does Test Harness support or which protocols does Test Harness support conformance testing for?
Really, it's just DNP. It's mainly DNP. We do have Modbus conformance testing. That's undergone some changes lately, so I couldn't tell you the status of where the Modbus group has gone with their conformance testing. We do have a version of conformance testing for Modbus in the test harness, and then DNP is being updated to match the latest spec.
Mm-hmm. Okay, next question. Is there any plan to include Python as an option to do scripting in the test harness in the near future. I'm going to throw that one over to you, Steve.
Yeah, so Python scripting already exists in the test harness. It's documented in the test harness manual, but I would have trouble winging it right here. Python scripting is different. It's very programmatic and is different than Tickle, but from the test harness point of view, yes, you can use it, and there are examples in the test harness manual as how to do it.
And I do see a number of questions coming in on automated testing, but they were coming in just as right before Matt did the demo, or as he was doing the demo. And I think a lot of them got answered through the demo, but if you still have questions on the automated testing functionality, please go ahead and submit those while we're still on.
As far as automated testing, if customers want, example code or it would be better if they can just send us a kind of a support request, and we can, craft some example scripts to show them rather than trying to do it through the chat, I think.
Okay, yeah, that's a great suggestion. So if someone has specific questions on the automated testing, absolutely, you can send that, I guess, directly to either sales@trianglemicroworks.com or support@trianglemicroworks.com, and you'll be lucky enough to work one-on-one with Alan on those.
If I can add to that, someone asked about whether that demo script.tickle that Matt was using is available. A superset of that file exists already with the test harness. We have samples for DNP and all the protocols that are automatically loaded to the test harness. So, the specific function, the specific procedure he called to run the demo is not in there, but one that does more than that is in the sample. It's a good starting point for writing your own Tickle scripts.
Great. I think that actually just answers one of the questions that just came in on that. So thanks for that.
And I'm sorry, one more. And again, I don't mean to tell you to read the manual, but the details of where to find it are in the manual. And rather than me try and wing it, I would look there to see where to, because I know you can say, well, where is it? But look in there and see. It'll tell you what directory they're in and how they're used.
Okay. I've got a couple of questions that were asked a little bit earlier. I'll just spend a minute or two on those. Some devices report analog database on deadband configurations. Does that exist in test harness for a slave simulation?
Yeah, since I answered that one, so I know the answer to that one. Yes, the test harness does have, for DNP, has deadband built into it. So, if you set deadband values for the analog inputs, they'll be used to determine when to generate events. Deadband algorithms, there are lots of them and they can be very complicated. The one that's used in the test harness is the simple, obvious one. If a value changes by more than the deadband value since it last reported, it will generate an event. So, there's not time deadband, and there's not lots of options for deadband, but there's the simple one, and it shows how deadband is used. And if you're exercising, if you're testing the master, it doesn't really matter why the Outstation decides to generate events. The key thing is it generates events when deadband is successful.
Okay, thanks, Steve. Okay, I think I'm going to stop there. The questions have slowed down a little bit, and we've kind of covered a couple of the ones that were asked earlier on. Again, as I mentioned, we will go through and answer all the questions that were submitted here online and send them out to anyone that attended the webinar. So be on the lookout for that. I want to thank everybody for joining us today. Thanks to our panel and to Matt for presenting and for taking the time to look a little bit more at a deeper dive into our testing tools. So thanks, everyone, and enjoy the rest of your day.